Welcome to the TrackPads Weekly Podcast, your ultimate destination for exploring the incredible history and fascinating stories of military life, history, and beyond. I'm your host, Dr. Jason Edwards, and this week we're diving into the legacy of one of the most iconic aircraft in U.S. history, the B-52 Stratofortress. This legendary bomber has shaped military strategy for over 7 decades, embodying innovation, resilience, and power. From Cold War deterrence to modern precision bombing campaigns, the Stratofortress has left an indelible mark in military history. Don't forget to like, subscribe, and check out the TrackPads newsletter at trackpads.com for multimedia content that brings these stories to life. You can also explore my published books by visiting my authors page at militaryauthor.me. The B-52 Stratofortress is one of the most enduring symbols of military aviation, representing a blend of technological ingenuity, strategic foresight, and unparalleled longevity. First introduced in 1955, this iconic bomber has remained a cornerstone of the U.S. Air Force for nearly 7 decades, adapting to global threats and advancements in warfare. While originally designed for high-altitude strategic bombing missions during the Cold War, its roles have expanded to include reconnaissance, precision strikes, and support for Allied operations. The aircraft's adaptability has enabled it to remain relevant in an era dominated by stealth fighters, drones, and hypersonic missiles, a testament to its exceptional engineering and versatility. The B-52's legacy is as much about its operational successes as its symbolic representation of American firepower and resilience. This episode will explore the legacy of the B-52 Stratofortress in detail, examining its historical context, design evolution, operational history, modernization efforts, and enduring significance. B-52's story is not just a chronicle of military innovation, but also reflects the changing nature of warfare and the enduring need for strategic deterrence. Its journey from the early days of the Cold War to its current role in 21st century operations offers valuable insights into the principles of resilience, adaptability, and technological foresight that define modern military aviation. History of bombers and the strategic context. The development of bombers can be traced back to the First World War, a period that marked the emergence of strategic bombing as a military concept. Early bombers such as the German Gotha G.4 and the Zeppelin Staaken demonstrated the potential of aircraft to strike targets far behind enemy lines. Though rudimentary by today's standards, these bombers introduced the idea of using aerial platforms to weaken the enemy's infrastructure and morale. Their relatively small payloads and limited range constrained their effectiveness, but they set the stage for more advanced designs that would dominate the skies in later conflicts. This period laid the foundation for the idea that air power could decisively shape the outcome of wars. World War II brought a dramatic leap in bomber technology and strategy as nations recognized the importance of air superiority and strategic bombing campaigns. Aircraft like the B-17 Flying Fortress, the B-24 Liberator, and the Avro Lancaster became synonymous with high-altitude precision bombing. These bombers featured innovations such as pressurized cabins, improved navigation systems, and increased payload capacities, allowing them to strike industrial and military targets with greater accuracy. The U.S. Air Force's bombing campaigns, such as those over Dresden and Tokyo, demonstrated the devastating power of strategic bombers when combined with concentrated air power. The lessons learned during these missions underscored the need for an even greater advancements in bomber technology to address emerging challenges. The introduction of the B-29 Superfortress marked a turning point in the evolution of bombers, particularly with its role in ending World War II. The B-29 was the first bomber to feature a pressurized cabin and remote-controlled defensive gun turrets, enabling higher altitude operations and greater crew safety. Its long range and ability to carry heavy payloads made it an ideal platform for missions such as the atomic bombings of Hiroshima and Nagasaki. These missions underscored the potential for bombers to deliver decisive, war-ending blows, solidifying their strategic importance. However, the end of World War II also signaled the beginning of the Cold War. This period demanded further innovation to meet the unique challenges of nuclear deterrence and global reach. As the Cold War escalated, the U.S. Air Force and its allies sought bombers capable of deterring Soviet aggression through the threat of nuclear retaliation. Early efforts relied on aircraft like the B-29 and its successor, the B-36 Peacemaker, which served as interim solutions while more advanced platforms were developed. These bombers faced limitations, including vulnerability to emerging Soviet air defenses and challenges related to speed and range. The introduction of jet-powered bombers such as the Soviet Tu-95 and the American B-47 Stratojet marked the beginning of a new era in strategic bombing. These aircraft incorporated jet propulsion, improving speed and operational altitude, but they also highlighted the need for a platform capable of carrying larger payloads over intercontinental distances. The development and design of the B-52. The U.S. Air Force recognized the need for a high-altitude, long-range bomber that could deliver nuclear payloads deep in enemy territory. The detailed specifications issued by the Air Force emphasized the importance of speed, range, and payload capacity, all of which were critical for deterring adversaries in an era dominated by the looming threat of the Soviet Union. Boeing, competing against other aviation giants at the time, submitted a bold proposal that ultimately won the contract. Despite initial skepticism about the feasibility of such an ambitious design, Boeing's innovative approach would soon revolutionize strategic bombing. Early concepts for the B-52 explored several configurations, including turboprop engines, before settling on jet propulsion. The decision to adopt jet engines was driven by the need for higher speeds and better performance at altitude, both essential for evading emergency Soviet air defenses. The aircraft's final design incorporated a swept-wing configuration which improved aerodynamic efficiency and allowed for extended range. The prototyping and testing phase began with developing the XB-52, an experimental model designed to refine the bomber's key systems and capabilities. This phase was marked by numerous challenges, including achieving the desired balance between stability, speed, and range. Engineers encountered difficulties in designing wings that could withstand the stresses of high-altitude flight while maintaining fuel efficiency. Changes were made to the wing structure, engine placement, and fuel systems to address these issues, resulting in significant performance improvements. Early test flights of the XB-52 provided critical lessons that shaped the final production models. Test pilots and engineers worked closely to identify and resolve issues, such as optimizing the aircraft's control systems and ensuring safe handling during takeoff and landing. The process revealed the importance of integrating advanced avionics for navigation and targeting, which would later become a hallmark of the B-52. These tests also demonstrated the aircraft's impressive payload capacity, confirming its ability to deliver a wide range of ordnance over vast distances. Despite setbacks and revisions, the XB-52's success validated Boeing's innovative design and silenced critics. The technical specifications and variants of the B-52. The B-52 is powered by 8 Pratt & Whitney jet engines, a defining feature that sets it apart from its contemporaries. These engines, mounted in pairs beneath each wing, provide the necessary thrust to propel the massive aircraft across intercontinental distances. Their efficiency has been a cornerstone of the B-52's ability to perform extended missions, particularly with aerial refueling capabilities. Over time, advancements in engine technology have further improved the aircraft's fuel consumption and reliability. The choice of 8 engines reflects the designer's emphasis on redundancy and power, ensuring the bomber's ability to fulfill its role even in the face of engine failure. The B-52's wingspan, measuring over 185 feet, is another critical component of its design. The swept wing configuration enhances aerodynamic efficiency, allowing the aircraft to operate effectively at high altitudes with lower air density. This feature was designed to enable the bomber to evade early air defense systems, providing it with significant tactical advantage. The wings also house the fuel tanks, contributing to the aircraft's impressive range. Combining the wing's structural strength and design ingenuity allows the B-52 to carry heavy payloads without sacrificing maneuverability. With a payload capacity of up to 70,000 pounds, the B-52 can deliver a wide variety of ordnance, from conventional bombs to nuclear weapons. This unmatched capacity enables it to undertake diverse missions, including strategic bombing, close air support, and long-range strike operations. The aircraft's bomb bays and external hardpoints are designed to accommodate many munitions, including precision-guided weapons and cruise missiles. Advanced avionics systems have played a crucial role in the B-52's effectiveness over decades of service. Early models introduced cutting-edge navigation and targeting systems, which have since been upgraded to include GPS technology and advanced radar capabilities. These systems provide precise targeting even in adverse weather conditions and enable the aircraft to operate in highly contested environments. Electronic countermeasure systems have also been integrated to protect the B-52 from enemy radar and missile threats. Defensive armament has been a hallmark of the B-52, particularly in its early models, which featured a tail gunner position armed with quad 50 caliber machine guns. Over time, these were replaced by automated systems to improve crew safety and effectiveness. Later iterations introduced electronic countermeasures, including radar jamming and decoy systems, further enhancing the aircraft's defensive capabilities. The production of the B-52 involved an extensive manufacturing process spearheaded by Boeing at its facilities in Seattle and Wichita. The aircraft's modular construction allowed for efficient assembly, ensuring a steady delivery rate to meet the Air Force's demands. Early models, such as the B-52A, served primarily as prototypes and test platforms, while later versions, like the B-52H, introduced significant advancements. The B-52H, the final production model, features more powerful and efficient engines, enhanced avionics, and greater operational range than its predecessors. One of the most significant innovations in the B-52's operational history was the introduction of aerial refueling capabilities. This advancement extended the aircraft's range dramatically, enabling it to perform missions across the globe without the need for forward basing. Refueling mid-air became a game-changer during the Cold War, allowing bombers to maintain airborne alert status for extended periods. Aero refueling remains critical to the B-52's operational strategy, ensuring its long-range strike capabilities in contemporary missions. Specialized role for B-52 variants further highlight the aircraft's adaptability. Reconnaissance versions were equipped with advanced sensors and surveillance systems, enabling them to gather critical intelligence during the Cold War. Other variants were modified to carry cruise missiles, extending the B-52's reach and precision in delivering standoff weapons. 744 B-52s were built throughout its production run, with the final aircraft delivered in 1962. Despite the end of production, the Air Force's commitment to maintaining and upgrading the existing fleet has ensured its continued service. The timeline of deliveries, from the early B-52As to the final B-52Hs, reflect the rapid pace of technological innovation during the Cold War. Each variant contributed to the aircraft's enduring legacy, cementing its status as one of the most iconic bombers in aviation history. The operational history of the B-52. During the Cold War, the B-52 was at the forefront of the U.S. Air Force's strategic bombing efforts, critical in deterring Soviet aggression. One of its most notable missions was Operation Chrome Dome, which kept nuclear-armed B-52s on continuous airborne alert. These missions ensured a constant state of readiness and underscored the bomber's role in maintaining the credibility of U.S. nuclear deterrence. In addition to airborne patrols, B-52s were strategically positioned at forward bases across Europe and Asia, allowing for rapid deployment in response to potential threats. The Cuban Missile Crisis highlighted the B-52's ability to project power as a show of force. During the crisis, B-52s flew missions near Soviet airspace to signal U.S. resolve and readiness to act. These missions served as a critical element of the U.S. strategy to pressure the Soviet Union into withdrawing its missiles from Cuba. The presence of nuclear-capable bombers on high alert not only demonstrated the U.S.'s military's capability, but also acted as a psychological deterrent. The B-52 also played a central role in NATO's nuclear deterrence strategy, providing a critical component of the alliance's defense posture. As part of the nuclear triad, B-52s ensured that the U.S. and its allies maintained a credible second strike capability. Regular Strategic Air Command (SAC) exercises tested the readiness of bomber crews and validated their ability to deliver nuclear payloads under combat conditions. These exercises involved complex scenarios, including rapid deployment and simulated penetration of enemy defenses, ensuring crews were prepared for real-world missions. The Vietnam War marked a shift in the B-52's operational focus from nuclear deterrence to large-scale conventional bombing. During Operation Rolling Thunder, the aircraft was deployed for strategic bombing missions against North Vietnamese targets, demonstrating its ability to deliver massive payloads with devastating effect. Later in Operation Linebacker II, often referred to as the Christmas bombing, B-52s were used in concentrated campaign to force North Vietnam to negotiate peace. This campaign, involving hundreds of sorties, showcased the bomber's capacity for sustained operations. However, these missions also revealed tactical challenges, such as targeting dense jungle environments where enemy forces often hid. The use of B-52s in Vietnam exposed vulnerabilities, particularly to surface air missiles, which led to significant losses. Countermeasures were developed to enhance the bomber's survivability, including electronic jamming and decoy systems. These adaptations improved the B-52's effectiveness in Vietnam and informed future strategies for operating in contested environments. The lessons learned during the conflict influenced U.S. airpower doctrine, emphasizing the need for precision and adaptability in modern warfare. Post-Vietnam, the B-52 transitioned to new roles in conventional warfare while maintaining its strategic deterrence capabilities. During Operation Desert Storm, it delivered precision strikes against Iraqi forces, showcasing its ability to adapt to modern conflicts. The bomber also played a significant role in NATO missions in Kosovo, where it was used to target critical infrastructure and military assets. In the War on Terror, B-52s conducted long-range strikes in Afghanistan and Iraq, providing close air support and precision bombing against insurgent targets. The shift from nuclear to conventional missions has highlighted the B-52's versatility in modern conflicts. Its ability to carry various precision-guided munitions has made it a critical asset in operations requiring strategic and tactical capabilities. Despite its age, the bomber has consistently demonstrated value in diverse operational scenarios, from large-scale conflicts to counterterrorism missions. Modernization of the B-52. The modernization of the B-52 Stratofortress has been crucial to maintaining its relevance in a rapidly evolving military landscape. A significant focus has been upgrading the aircraft's avionics, transitioning from outdated analog systems to advanced digital displays. These new systems provide pilots with enhanced situational awareness, streamlining the management of complex missions. Adding advanced heads-up displays and multifunction screens has improved the aircraft's ability to adapt to modern combat environments. These upgrades ensure the B-52 can integrate seamlessly with other assets in the joint force, enhancing its operational capabilities. Enhanced communication systems have been another cornerstone of the B-52's avionics modernization. Integrating secure, high-speed data links allows the bomber to communicate with other aircraft and command centers in real time. This capability is particularly important in multi-domain operations, where coordinated efforts across air, land, sea, and cyber domains are critical. These communication upgrades also enable the B-52 to act as a command and control platform in certain scenarios, extending its utility beyond traditional bombing missions. The introduction of satellite-based navigation and GPS targeting has transformed the precision and effectiveness of B-52 missions. Unlike earlier systems, which relied on less accurate inertial navigation, modern GPS-based systems allow for pinpoint targeting of enemy assets. This capability has significantly reduced collateral damage and increased mission success rates in complex operational environments. Integrating advanced radar systems further enhances the B-52's ability to detect and track threats, even in adverse weather conditions. Electronic warfare capabilities have also been integrated into the B-52 as part of its modernization efforts. These systems include advanced jamming technology to disrupt enemy radar and communications, enhancing the aircraft's survivability in hostile airspace. The addition of electronic countermeasures, such as chaff and flare dispensers, further protect the bomber from modern surface-to-air missile threats. These upgrades align with the Air Force's emphasis on survivability and adaptability, enabling the B-52 to operate effectively against increasingly sophisticated adversaries. A critical aspect of the B-52's modernization involves the replacement of its aging engines with more fuel-efficient models. The current Pratt & Whitney TF-33 engines, which have powered the bomber for decades, are slated to be replaced with modern alternatives. These new engines will reduce maintenance costs and extend the aircraft's operational range and performance. Improved fuel efficiency will allow the B-52 to remain airborne longer, reducing reliance on aerial refueling in certain missions. Selecting and testing new engine candidates has been a meticulous endeavor. Multiple engine manufacturers have proposed designs that meet the Air Force's stringent performance, reliability, and efficiency requirements. Rigorous testing is underway to ensure that the selected engines can integrate seamlessly with the B-52's airframe and systems. This includes assessing thrust output, fuel consumption, and long-term maintenance needs. Once the testing is complete, the implementation phase will begin, involving retrofitting the entire B-52 fleet with new engines. The timeline for engine replacement reflects the complexity of integrating such a critical upgrade into an aircraft with decades of service. Initial retrofitting is expected to begin in the mid-2020s, with full fleet modernization projected to take several years. This phased approach ensures minimal disruption to operational readiness while allowing time for adjustments based on initial results. Once completed, the engine replacement program will extend the B-52's service life into the 2050s and beyond. Weapon system enhancements and structural improvements of the B-52. The B-52 has undergone significant weapon system enhancements to remain a relevant and powerful platform in modern warfare. One key upgrade has been the integration of Joint Direct Attack Munitions, JDAMs, cruise missiles, and hypersonic weapons. This capability allows the B-52 to deliver various advanced munitions, ensuring its effectiveness against diverse threats. The ability to carry hypersonic weapons further solidifies its role in strategic deterrence, providing the Air Force with a cutting-edge tool for rapid response scenarios. Expanding the B-52's payload options has been another critical focus of modernization. In addition to traditional bombs and missiles, the aircraft can now deploy a range of specialized munitions, from bunker busters to electronic warfare payloads. This versatility enables the B-52 to adapt to different mission requirements, whether conducting strategic strikes or providing close air support. The aircraft remains an indispensable asset for conventional and unconventional operations because it accommodates various weapon types. Integrating standoff weapons has significantly increased the B-52's survivability in high-threat environments. Standoff weapons, such as cruise missiles, allow the bomber to engage targets from a safe distance, reducing the risk of exposure to advanced enemy air defenses. This capability has proven essential in modern conflicts, where adversaries deploy increasingly sophisticated radar and missile systems. By leveraging standoff weapons, the B-52 can maintain its strategic impact while minimizing the risks to its crew and airframe. The B-52's ability to deploy smart munitions with pinpoint accuracy has transformed its role in precision warfare. Smart weapons, guided by advanced targeting systems, allow the bomber to strike specific targets with minimal collateral damage. This capability is particularly valuable in asymmetric warfare, where precision is critical to achieving mission objectives without escalating conflicts. By integrating these technologies, the B-52 has shifted from a platform designed for area bombardment to one capable of surgical strikes. Structural improvements have also been vital in extending the life of the B-52 airframes, many of which have been in service for decades. Reinforcements to critical structural components, such as the wings and fuselage, have helped maintain the bomber's integrity under the stress of modern operations. These upgrades ensure the aircraft can continue to carry heavy payloads and operate at peak performance levels. Refurbishments have also focused on replacing aging materials with more durable alternatives, enhancing the aircraft's resilience and reliability. Upgraded landing gear has enabled the B-52 to accommodate increased takeoff weights, a necessity given its expanded payload capacity. The enhanced gear system ensures safe operations during high-intensity missions, particularly when operating from forward-deployed air bases with varying runway conditions. This improvement aligns with the Air Force's emphasis on maintaining operational readiness across various environments. By addressing this critical component, the modernization program ensures that the B-52 can support the demands of both current and future missions. Refurbishing critical components, including fuel tanks and hydraulic systems, has improved the bomber's overall performance and safety. Aging parts have been replaced or upgraded to ensure the aircraft's reliability during extended missions. These efforts have also focused on reducing the maintenance burden associated with older airframes, increasing the bomber's availability for operational deployments. Survivability enhancements have been a priority in modernizing the B-52's structure and systems. Advanced defensive systems, including radar jamming and infrared countermeasures, provide additional protection against modern threats. These improvements align with the evolving nature of air combat, where survivability is paramount in contested environments. The current role and engineering legacy of the B-52. The B-52 is critical in global power projection through strategic bomber patrols. These missions demonstrate the United States' ability to deploy air power rapidly and effectively globally, signaling strength to allies and adversaries. The bomber's long range and substantial payload capacity make it an ideal platform for maintaining a visible deterrent in key regions. Regular patrols in contested areas like the Indo-Pacific underscore its importance in countering potential threats and reassuring allied nations of U.S. commitments to regional stability. The B-52 has taken on close air support roles in modern asymmetric warfare, providing critical firepower in conflicts against non-state actors and insurgent groups. Its ability to loiter for extended periods and deliver precision-guided munitions has proven invaluable in supporting ground operations. The bomber's large payload allows it to carry various munitions, from JDAMs to cluster bombs, enabling it to address multiple tactical needs. This flexibility has made the B-52 a key component in campaigns like Afghanistan and Iraq, where its precision and endurance have provided significant operational advantages. Reconnaissance and intelligence gathering have also become integral to the B-52's modern missions. Equipped with advanced sensors and communication systems, the aircraft can provide real-time intelligence to commanders in the field. This capability allows for better situational awareness and more effective mission planning, particularly in complex operational environments. Reconnaissance missions conducted by the B-52s have been critical in monitoring adversary activities, identifying potential threats, and supporting broader military objectives. Deterrence missions remain a cornerstone of the B-52's operational role, particularly in regions with heightened tensions like the Indo-Pacific. The bomber signals U.S. resolve and capability to potential adversaries by conducting regular flights near contested territories. These missions serve as both a warning and a reassurance to allies, emphasizing the U.S. commitment to collective security. The B-52's presence in these regions highlights its enduring value as a tool for maintaining strategic stability. Training exercises with NATO and allied air forces further illustrate the B-52's importance in fostering international cooperation. These exercises allow allied forces to practice coordinated operations and integrate their capabilities. The B-52's participation enhances interoperability among partner nations, ensuring readiness for joint missions in various scenarios. These training missions also showcase the bomber's adaptability as it seamlessly integrates with modern aircraft and technology. The engineering feats behind the B-52 have ensured its design longevity, unmatched by any other military aircraft. Introduced in 1952, the bomber has remained operational for nearly 7 decades, a testament to its robust construction and forward-thinking design. Its airframe, capable of carrying heavy payloads and enduring extreme conditions, has proved remarkably resilient. This durability has enabled the aircraft to adapt to evolving mission requirements, from nuclear deterrence to precision bombing. Despite its longevity, the B-52 faces operational challenges that require intensive maintenance and modernization. Aging airframes demand constant upkeep to ensure safety and performance, increasing the logistical burden on the Air Force. The bomber's speed, while sufficient during its inception, now lags behind modern aircraft, limiting its ability to evade advanced air defenses. In contested environments, the B-52's reliance on aerial refueling poses additional risks, as it extends mission times and exposes both the bomber and its supporting tankers to potential threats. The risk of advanced enemy air defense systems represents another significant obstacle for the B-52. Modern integrated air defense networks are designed to detect and target non-stealthy aircraft, increasing the bomber's vulnerability in certain scenarios. However, upgrades to electronic warfare systems and standoff weaponry have mitigated some risks. By leveraging its long range and standoff capabilities, the B-52 can continue to operate effectively while minimizing exposure to hostile systems. Ultimately, the B-52's engineering legacy and operational importance underscore its status as a cornerstone of U.S. air power. Its unparalleled longevity, adaptability, and versatility have allowed it to bridge the gap between generations of military technology. While challenges remain, the bomber's continued modernization and operational flexibility will remain key to U.S. and allied defense strategies for decades. The cultural and historical significance of the B-52. The B-52 Stratofortress has left an indelible mark in popular culture, symbolizing military power and the Cold War era. Its most iconic portrayal is in the film Dr. Strangelove from 1964, where a fictional B-52 mission dramatizes the risks and absurdities of nuclear brinksmanship. This satirical depiction cemented the aircraft's association with Cold War deterrence and the precarious balance of power during that period. Similarly, By Dawn's Early Light in 1990 showcased the B-52's role in delivering strategic strikes, emphasizing its importance in hypothetical global conflicts. These portrayals reflect the aircraft's pervasive influence on public perceptions of air power and strategic warfare. In literature and media, the B-52 symbolizes Cold War deterrence and the technological race between superpowers. This symbolism extends to its representation in art and photography, where the B-52 is often depicted as a silent yet powerful guardian of U.S. security. The B-52 has also been used to showcase U.S. military capabilities in public demonstrations and its depiction in popular media. Air shows featuring the bomber highlight its massive size, impressive payload capacity, and longevity, captivating audiences worldwide. Video games and flight simulators have immortalized the B-52, allowing players to experience its operations in strategic and tactical scenarios. Titles such as Microsoft Flight Simulator and War Thunder feature the bomber, reinforcing its reputation as a symbol of American air power. These cultural depictions keep the B-52 relevant in the public consciousness, bridging the gap between military history and modern entertainment. The future prospects of the B-52. The B-52 is expected to remain operational through the 2050s and possibly beyond, securing its place as one of the longest-serving military aircraft in history. The U.S. Air Force is committed to aligning the bomber's capabilities with the evolving needs of modern warfare. Ongoing modernization programs, as discussed earlier, aim to equip the aircraft with cutting-edge technologies, ensuring its effectiveness in a multi-domain operational environment. The prospect of eventually retiring the B-52 has sparked debates about its long-term viability and the need for next-generation replacements. Proponents of maintaining the fleet argue the bomber's proven track record and ongoing modernization make it a cost-effective and reliable asset. The B-52's ability to adapt to evolving mission requirements, from nuclear deterrence to precision strikes, further supports the case for its continued use. However, critics suggest that investing in newer platforms with stealth and advanced capabilities may better address the challenges of future conflicts. Economic considerations also play a significant role in discussing the B-52's service life. While substantial, the costs associated with maintaining aging airframes are often outweighed by the expense of developing and fielding entirely new bombers. The Air Force's commitment to extending the B-52's operational life reflects its strategic value and cost efficiency. This balance between operational needs and budgetary constraints will continue influencing decisions about the aircraft's future. Despite its strengths, though, the B-52 faces future challenges in maintaining its competitive edge. Advancements in enemy air defense systems, including integrated radar networks and hypersonic interceptors, pose significant threats to the bomber's survivability, while upgrades to electronic warfare systems and standoff weaponry mitigate some risks. The B-52's lack of stealth capabilities makes it increasingly reliant on complementary assets. Addressing these challenges will require continuous innovation and strategic planning to ensure the bomber remains effective in contested environments. In conclusion, the B-52 Stratofortress is one of the most remarkable achievements in military aviation history, combining longevity, adaptability, and unmatched operational success. Over nearly 7 decades of service, it has evolved from a Cold War-era strategic bomber into a versatile platform capable of supporting various missions. From nuclear deterrence during the height of geopolitical tensions to precision strikes in modern conflicts, the B-52 has consistently demonstrated its value as a cornerstone of U.S. air power. Its role in shaping air power doctrine and its contributions to global security has solidified its place in the annals of military history. Few aircraft have achieved the iconic status of the B-52, which remains a symbol of American innovation and resilience. Its engineering brilliance, combined with the foresight of its designers, has ensured its continued relevance through successive generations of technological advancements. The bomber's ability to adapt to changing military needs, from nuclear missions to conventional operations, exemplifies the principles of versatility and strategic foresight. This legacy of endurance and effectiveness underscores the B-52's significance as a testament to the ingenuity of military aviation. As it continues to serve well into the 21st century, the B-52's impact on air power and strategy remains unparalleled. Its presence in modern conflicts, alongside its role in deterrence and allied operations, highlights its enduring importance. The Air Force's commitment to modernization ensures that the B-52 will remain a critical asset in addressing future challenges, whether as a symbol of strategic deterrence or a platform for technological innovation. The B-52's contributions to air power will leave a lasting legacy for generations to come. Thank you for tuning into this episode of the TrackPads Weekly Podcast. Don't forget to check out the TrackPads online newsletter, where we take things to the next level with multimedia content. Each issue features fascinating and informative photos, videos, and articles that bring stories of the military to you in a dynamic and engaging way. Be sure to subscribe at trackpads.com to stay informed, and check out my books at militaryauthor.me.